We are on an impact course in common drop toward our adjoining huge universe, Andromeda, an arrangement of a few 100 billion stars. The Andromeda world was the cosmic system that uncovered the way that the universe and creation itself didn't spin around us. It was confirmation that the smooth way isn't the main world in the universe, and that we may very well be a bit in the more noteworthy universe. We have learned a lot about Andromeda over the past century, but the majority of that information came from Earth-based observations. Presently, with instruments like the James Webb Space Telescope, the situation are unique. Turns out Andromeda isn't what we thought it was. Information from the James Webb Telescope has stunned the whole academic local area. Go along with us as we investigate reality with regards to the Andromeda universe and the stunning disclosures that have overturned 100 years of understanding. A little more than 100 years back, the smooth way was normally seen as a band of weak, wispy, whitish light extending across the night sky. This insight was affected by the restricted innovation of the time, which kept cosmologists from knowing individual stars inside the smooth way. The Milky Way was associated in a variety of ways with the meeting point of the celestial and terrestrial spheres, the center of all creation. In the early 17th century, the Italian astronomer Galileo Galilei revolutionized our understanding of the Milky Way. Utilizing his recently evolved telescope, he mentioned momentous observable facts that tested the common Aristotelian cosmology. He found that the smooth way was a diffused band of light, however an enormous assortment of individual stars, planets, and other divine items. The smooth way cosmic system and the closest world to us, Andromeda, are only two of an expected 100 billion systems in the apparent universe. This indicates that we are able to count the number of stars in the universe that can be seen. Through his perceptions, Galileo exhibited that the smooth way was not at the focal point of the universe, yet rather a huge scope of stars dispersed all through space. In 1750, English cosmologist Thomas Wright proposed another speculation in his work, a unique hypothesis or new theory of the universe. Wright hypothesized that the smooth way was not an irregular dispersion of stars in space but rather a totally level layer of stars. He likewise recommended that a piece of this tremendous design was our own planetary group. Wright's speculation was a step in the right direction in grasping the construction of the smooth way. However, it was as yet restricted by the observational innovation accessible at that point. Given the limitations, it is not surprising that astronomers still believed that the Milky Way was all there was. However, by the early 1800s, astronomy had advanced significantly, and by the early 1900s, things were rapidly changing. During the 1920s, American cosmologist Edwin Hubble made an extraordinary disclosure utilizing the 100-inch prostitute telescope at Mount Wilson Observatory. Hubble noticed far-off nebulae past the smooth way. He demonstrated, through his observations and analysis, that these objects were not part of the Milky Way but rather distinct galaxies with billions of stars each. One of the nearest of these worlds was the Andromeda universe. The Andromeda system, otherwise called M31, has a rich history of perceptions that date back hundreds of years. The Persian astronomer Abd al-Rahman al-Sufi described this celestial object as a small cloud in star charts from the 10th century, making it one of the earliest known records. Because it appears to be surrounded by a faint cloud from Earth, it was given the name Little Cloud. The meaning of these perceptions lies in the way that al-Sufi had the option to distinguish this far-off astronomical element without adjustable instruments, depending exclusively on his sharp vision and perceptions. This was conceivable on the grounds that Andromeda is one of only a handful of exceptional worlds in the universe noticeable from Earth's surface without extraordinary instruments. It will be visible in the open sky if you only know where to look. While you can't see a lot of detail, you can perceive that some different option from the typical stars is there. Simon Marius did not provide a more in-depth description of the Andromeda galaxy based on telescopic observations until 1612. His work established the groundwork for future space experts to concentrate on this enormous vast construction. Afterward, in 1764, the famous French cosmologist Charles More Chaotic recorded the Andromeda world as M31 in his notable More Chaotic list, erroneously crediting its revelation to Simon Marius, uninformed about al-Sufi's prior work. In spite of this, More Chaotic assumed a huge part in making Andromeda famous. Astronomers around the world tried to learn more about this mysterious galaxy for nearly a century after this, each one building on the previous findings. An important observation made in 1864 by English astronomer William Huggins marked a significant advance in our understanding of Andromeda. He concentrated on Andromeda's range and seen it contrasted from that of a normal vaporous cloud, preparing for a more profound comprehension of Andromeda. Andromeda is a gigantic, enormous design, with a mass assessed to be somewhere in the range of 1 and 2 trillion times that of our Sun. This Goliath universe, found moderately near us in the immeasurability of room, has a rich and complex history. Andromeda is quite ancient in cosmic terms, according to scientists, with an estimated age of 10 billion years. Its age indicates a long and multifaceted history of development and advancement. One charming part of Andromeda's starting point is the speculation that it shaped through the converging of a few more modest proto-worlds. More than billions of years, these more modest cosmic substances step by step met up under the power of gravity to frame the magnificent Andromeda universe we see today. The growth and structure of galaxies are shaped by galaxy mergers, which occur frequently throughout the universe. However, everything occurs so sluggishly that you can't see it until critical improvement has been made. For quite a while, cosmologists thought Andromeda was essentially more gigantic than our own smoothway universe. According to a goal perspective, this misstep was not difficult to make since we're inside the smoothway, and review Andromeda from Earth makes it look so enormous that it appeared nothing could think about. Notwithstanding, late examination has driven researchers to decrease their gauge of Andromeda's mass while at the same time expanding the mass ascribed to the smoothway. Accordingly, we presently comprehend that the majority of these two inestimable Goliaths are a lot nearer than recently suspected. Thus, assuming you were in Andromeda and taken a gander at the smoothway, you'd see a similarly enormous cosmic system. The Milky Way's enormity is also brought to light from this angle. Space experts settle on Andromeda's actual aspects. It's known to extend farther than our own smooth way. These supermassive dark openings are unbelievably thick locales in space, where a tremendous measure of mass is concentrated inside a little volume. The AGN appears to have 2 points of concentration, indicating that there are 2 distinct regions where light and other forms of radiation are more intense than in the surrounding areas, as observed by astronomers using advanced telescopes like the Hubble Space Telescope. The more brilliant fixation is the second mark of concentration, only somewhat off the genuine cosmic focus, where the supermassive dark opening lies. The mass of this dark opening is assessed to be between 110 million to 230 million times that of our Sun's. Supermassive dark openings are normal in system communities, including our own smoothway, and assume a vital part in the development and elements of universes. At the point when matter, like gas and stars, gets excessively near a supermassive dark opening, it frames a growth plate around it. The AGN's luminous disk of swirling material heats up and emits a lot of radiation. A brighter point of concentration has been observed in Andromeda's AGN near the central supermassive black hole. Unique gravitational interactions between the black hole and nearby stars cause this feature. In the core of the Andromeda cosmic system, the supermassive dark opening applies a strong gravitational draw on encompassing stars. As these stars circle the dark opening, they follow curved ways, like how planets circle the Sun in our planetary group. At a point known as perihelion, when the stars are closest to the black hole, the gravitational forces are at their strongest, causing the stars to move at their fastest speeds. As a result, a cluster of stars forms, releasing energy in the form of visible light. The expanded convergence of stars and radiation makes the more splendid place of focus saw in Andromeda's AGN. One more intriguing element of the Andromeda cosmic system is its overflow of globular bunches, tight gatherings of stars that circle the world's middle like satellites spinning all over a world. Andromeda is assessed to hold onto around 460 of these globular bunches, fundamentally more than our smooth way, which has around 200. A portion of these groups in Andromeda are old, with ages assessed to surpass 10 billion years. Astronomers studying the early stages of galaxy formation benefit greatly from these clusters. Researchers accept numerous globular bunches in Andromeda were framed through the converging of more modest systems with Andromeda north of billions of years. Some of the stars in the smaller galaxies were captured by Andromeda during these mergers, and they eventually became part of the globular cluster system it created. Concentrating on these bunches gives bits of knowledge into Andromeda's arrangement history and the cycles engaged with system consolidations. Andromeda is home to a large number of satellite galaxies in addition to its extensive globular cluster system. These more modest universes circle around Andromeda, similarly as the enormous and little Magellanic mists circle the Smooth Way. A portion of these satellite systems are accepted to have shaped alongside Andromeda, while others were probably caught during vast experiences with different universes. The complicated collaborations among Andromeda and its satellite cosmic systems offer important signs to the elements of universe development and advancement. One interesting part of Andromeda's satellite worlds is their different properties. Some are wealthy in gas and effectively shaping stars, while others are moderately gas-poor and display little star arrangement action. These varieties in properties probably reflect contrasts in the satellite universe's development accounts and their connections with Andromeda. The inquiry emerges with regards to how Andromeda's dynamic cosmic core AGN looks to our Smooth Way's own AGN. Sagittarius A*, or SGR-A* for short, the AGN of the Milky Way, is a much quieter and less active nucleus than Andromeda's. Supermassive black holes are at the center of both galaxies, but their behavior is different. Sargent A** is in a state of relative dormancy, releasing only a small amount of radiation and remaining relatively calm. Andromeda's AGN, conversely, is more vigorous and dynamic. This distinction in AGN movement might be because of how much matter encompassing each supermassive dark opening. The black hole in Andromeda consumes more material nearby, resulting in increased energy output and brighter AGN. Conversely, SGR-A* in our Smooth Way could have less material around it, prompting lower energy levels and a calmer AGN. Notwithstanding these distinctions, both Andromeda and the Smooth Way are comparable in numerous alternate ways, including their sizes, masses, and designs. These likenesses and contrasts give significant bits of knowledge into how worlds develop and how their focal dark openings impact their general elements.